Good day, my name is John Francis A. Ramos from CE1A, and I will be discussing the basic and compound prepositions for today's video. But first, let us know the learning objectives. At the end of the discussion, the student should be able to know the meaning of logic, understand the historical background of logic and mathematical reasoning, identify the meaning of the proposition and its properties, understand what is a compound proposition, understand the truth values, use and apply the truth table for conjunction, disjunction, and negation, know and understand the symbols used for conjunction, disjunction, and negation, know how to apply compound propositions with the combination of conjunctions, disjunctions, and negations. We have our learning discussion, and these are: what is logic, historical background of logic and mathematical reasoning, proposition and its properties, compound proposition, truth values, truth table for conjunction, disjunction, and negation, logical operators and symbols used for conjunction, disjunction, and negation, compound propositions applying combinations of conjunction, disjunction, and negation. Now, let's define logic. According to Merriam-Webster, logic is something that forces a decision apart from or in opposition to reason. It also means the science of formal principles of reasoning. Aristotle, on the other hand, says that logic is the instrument by means of which we come to know anything. He also said that it's a new and necessary reasoning. New because it allows us to learn what we do not know, and necessary as the conclusions are inescapable. But really, what is logic? Logic came from the Greek word logos, meaning reason. It studies the methods and principles used to distinguish correct from incorrect reasoning, and it deals with propositions or statements that are only capable of being true and false. Before continuing, let us first discuss the historical background and mathematical reasoning of logic. It all started in ancient Greece with Parmenides in 5th century BCE, who invented logic while living on a rock in Egypt. This is because he was the first philosopher to use an extended argument for his views rather than merely proposing a vision of reality make. These occurrences makes him compete with Aristotle for the title of father of logic, but it is widely known to be Aristotle rather than Parmenides. The reason for this is he are only using arguments but he is not studying them. He never systematically formulated or studied principles of argumentation in their own right. He is then followed by Zeno of Elea, who is the disciple of Parmenides. Zeno of Elea authored many arguments which is collectively known as Zeno's paradoxes. He uses a logical strategy known as reductio ad absurdum for establishing a claim by showing that the opposite of his arguments leads to preposterous results. This alone proves that Zeno's argument recognize and reflect on the general pattern of logic. Then we have the Sophists from 500 BC. The Sophists were a group of philosophers in ancient Greek. They cultivated the art of defending or attacking a thesis by the means of arguments. It is also true that the Sophists were instrumental in bringing argumentation to the central position. The Sophists were among the first people to demand that the moral claims be justified by reasons. Protagoras, who is part of the Sophists, is reported to have been the first to distinguish different kinds of sentences, questions, answers, prayers, and injunctions. Prodicus, another member of the Sophists, appears to have maintained that no two words can mean exactly the same thing. He also devoted much attention to carefully distinguish and defining the meanings of apparent synonyms. These contributions will later on be one of the pieces of information that shapes the logic that we know today. Socrates, from 470 to 399 BCE, is said to have attended Prodicus' lectures, one of the Sophists. Socrates pursued the definition of things, especially the realm of ethics and values. These investigations conducted by the means of debate and argument as portrayed in the writings of Plato, Socrates' student, which reinforced great interest in argumentation and emphasized the importance of care and rigor in the use of language. Plato, 428 to 348 BCE, continued the work started by Socrates, his mentor, and the Sophists. In the Sophists, he distinguished affirmation from negation and made the important distinction between verbs and names, which includes both nouns and adjectives. He remarked that a complete statement, logos, cannot consist of either a name or a verb alone, but requires at least one of each. This observation indicates that the analysis of language had developed to the point of investigating the internal structures of statements in addition to the relationships of statements between each other. This progress will then be developed by student Aristotle 384-322 BCE, who is labeled as the father of logic by many. Aristotle conceived logic as the study of argument and the correctness of argumentation. He undertook the systematic study of logic, where Plato used dialectic as both a method of reasoning and a means of a philosophical training. Aristotle established a system of rules and strategies for such reasoning. Aristotle produced 6 works on logic, known collectively as the Organon. The first of these, the Prior Analytics, being the first explicit work in formal logic. Medieval logic is led by Boethius 480 to 524, who translated Aristotle's categories and did the interpretation, and Polybius Isagoge, and his translations were much more influential compared to the others who translated such literary and logical texts. He also translated the rest of Aristotle's Organon, which have the Latin West from the words of Greek philosophers. In here, Aristotelian logic or dialectics was studied along with grammar and rhetoric as one of the 3 main strands of the trivium, the foundation of a medieval liberal arts education. Peter Abelard 1079 to 1142 spread logic in Arabia, as Abelard's fertile investigations raised logical study in medieval Europe to a new level, as his works and commentaries are said to show familiarity to Boethius' works, but Abelard's go beyond because his are much more easier to understand. Additionally, his achievement is all the more remarkable since the sources at his disposal were the same ones that had been available in Europe for the preceding 600 years: Aristotle's categories and the interpretation, and Polybius Isagoge, which are significant in the realm of logic. Immanuel Kant 1724-1804 focuses on the formal and systematic character of logic as a strongly proven or apodictic doctrine. He insists that formal logic should be abstract from all the content of knowledge and deal only with our faculty of understanding and our forms of thoughts. According to Kant, considers logic to be short and very general, but it should be certain. Gottlob Frege, 1848-1925, founded modern mathematical logic. He attempted the first formulation of higher-order logic. Frege also presented the first coherent and full analysis of variables and functions. He is also the first to show it is possible to reduce all truth functions to negation and the conditional, made the first clear distinctions between actions and inference rules in a formal system. As such, he is called the father of modern logic. All this new logic expanded in the joint work Principia Mathematica, which is much broader in scope than Aristotelian logic, and even contains classical logic within it. It resembles a mathematical calculus and deals with the relationships of symbols to each others. Now, let's proceed with the proposition and its properties. Let us first define proposition. Proposition is a declarative sentence which is either true or false. It must be one or the other, and it can't be both at the same time. We're not talking about Schrödinger's cat after all. For further understanding, here are some examples. Manila is the capital of the Philippines. This is a proposition. The truth value is true. 3 is an even integer. This is also a proposition. The truth value is false. Now, pay attention to this. This is not a proposition, as it is an imperative sentence, not a declarative sentence. What time is it? This is also not a proposition. It is a form of question. I am telling the truth. Not a proposition. Even though the sentence is in declarative form, it is neither true nor false. There are 2 kinds of proposition: simple and compound proposition. Simple proposition gives information about a single fact statement and it's independent. Example, August is the 8th month of the year. It just tells us a single fact or a proposition, which is August is the 8th month of the year. We can observe and say that there is only one statement. Compound proposition, on the other hand, gives information about 2 or more fact or statement, and it's dependent. It contains 2 or more simple propositions, which is connected by logical connectives and or, which are to be discussed later. But there are more which is not covered by my topic, and these are if then and it and only if. Example, 4 is an even number and 7 is less than 12. we can observe that there is the logical connective and, which tells us this is a compound proposition. We can also say that there are two statements within this proposition, and these are 4 is an even number and 7 is less than 12. More example of simple proposition. 8 plus 28 is 36. This is simple proposition. The truth value is true. Earth is the 5th planet in the solar system. This is also a simple proposition. The truth value is false. More examples of compound proposition. Either logic is fun and interesting or it is boring. It is connected using the logical connective and or. It also consists of 3 simple propositions. Logic is fun, logic is interesting, and logic is boring. Mariana Trench is the Mariana Trench is the deepest part of the ocean and it's near the Philippines. It is connected using the logical connective and it consists of 2 simple propositions. Mariana Trench is the deepest part of the ocean and Mariana Trench is near the Philippines. Truth values is the attribute assigned to a proposition in respect if it is true or false, which in classical logic has only 2 possible values, true or false. True is denoted by T or 1, false is denoted by F or 0. Truth table is used to determine when a compound statement is true or false, and I will discuss conjunction, disjunction, and negation. Conjunction is where the truth value is only true when both P and Q are true. Disjunction, on the other hand, is where the truth value will be true when either P or Q is true, while negation's truth value is opposite of the proposition. Let us start with the truth table of conjunction. We can read the upper left of the table as P and Q. According to its definition, the truth value is only true when both P and Q are true, meaning if there is one false in any proposition, P or Q present, then the truth value will be false. The truth value will only be true if both proposition is true. Examples. Determine whether each statement is true or false. 5 is a whole number and an even number. 2 is a prime number and it is also an even number. Now for the answers. For the number 1 is a false proposition as 5 is not an even number. Number 2 is a true proposition because each simple proposition is true. On the other hand, according to the definition of disjunction, the truth value will be true when either P or Q is true. Applying this to the truth table of disjunction, if there is one true in any proposition, P or Q present, then the truth value will be true. The truth value will only be false if both proposition is false. We can read the upper part of the table as P or Q. Examples. Determine whether each statement is true or false. Seoul is the capital of South Korea, or Tokyo is the capital of Japan. The moon is made of cheese, or it has a gravity. Now for the answers. 1 is a true proposition as each simple proposition is true. Number 2 is a true proposition also because the moon has indeed gravity. Finally, negation is easier out of the 3 as according to its definition, the negation's truth value is opposite of the proposition. Meaning if the proposition is true and we negated it, the value will be false. And if the proposition is false and we negated it, the value will then be true. Examples. Write the negation of each statement. Number 1. Elon Musk is a billionaire. This proposition is true. Number 2. Taylor Swift didn't win the Album of the Year at the 21 Grammys. This proposition is false. Now for the answers. Elon Musk is not a billionaire. This negated proposition is now false. Taylor Swift did win the Album of the Year at the 2021 Grammys. This negated proposition is now true. Let's proceed with the logical operators and symbols used for conjunction, disjunction, and negation to further clarify things. Conjunction has the symbol of an upside down V and it can be read as AND. Disjunction meanwhile has the symbol of an upright B and can be read as OR. Negation on the other hand has a diacritical mark or a wavy line and can be read as NOT. Example for conjunction, disjunction, and negation. P is the statement, John is a civil engineer, and Q is the statement, John passed the board exam. P and Q John is a civil engineer and he passed the board exam. P or Q. John is a civil engineer or he passed the board exam. Not P and not Q. John is not a civil engineer and he didn't pass the board exam. Compound prepositions applying combinations of conjunction, disjunction, negation. Now, let's apply what we have learned so far with example 1. Construct a truth value for not quantity of P and Q. To construct a truth table with two prepositions, start by putting two trues and two false respectively on P, and alternate of true and false on Q. Then it all depends on the given preposition, in this case, not quantity of P and Q. To not complicate things, let's start with the preposition within the parentheses. As this is a conjunction, if there are any false present, the true value will be false, and if only if the both are true, then the truth value will then be true. So, the truth value for the column P and Q are as follows: true, false, false. Now, we need to negate these to finally complete the truth table. Negating is just the opposite of the proposition. So, false, true, and true, and true. And we now completed the truth table for not quantity of P and Q. Construct a truth value for not quantity of P and not Q. Once again, start by putting two trues and two false respectively on P and alternate of true and false on Q. Now, we must first negate Q before proceeding with the conjunction within the parentheses. So Q's negations are false, true, false, true. Now, we can proceed with the conjunction of P and not Q. The truth values for the will be false, true, false, and false. As I said before, if there is one false in any proposition, P and Q, then the truth value will be false. And if only two propositions which are true, then only at that instance the truth value will be true. Now, to finalize the truth table, negate the P and not Q. The answer will then be true, false, true, and true. And it is just the opposite of the proposition. And now we completed the truth table for not quantity of P and not Q. Now, for example 3, construct a truth table for P and not P or Q. As usual, start by putting two trues and two false respectively on P and alternate of true and false on Q. In this case, we need to get the truth value of the disjunction P or Q. As I mentioned before, if there are any true present, the truth value will be true. And if and only if both are false, then the truth value will be false. So the truth value is as follows: true, 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 then false. Now, we need to negate them. So false, 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 true. Finally, we need to get the conjunction of P and not quantity of P and Q. Now, if there are any false present, the truth value will be false, and if and only if both are true, then the truth value will be true. So the truth value to complete the table will be all false. There is this example with 3 logical variables. I'll be explaining this in my report in the Google Meet when it is my time to report online. This is because this is too complex, so it might cause confusion to many. I want to be hands-on as much as possible, specifically with this example. I will also provide more examples in my report within my time in Gmeet. So now let's proceed with the summary. Logic came from the Greek word logos, meaning reason. It deals with the propositions or statements that are only capable of being true and false. Proposition is a declarative sentence which is either true or false. It must be one or the other, and it can't be true and false. Simple proposition gives information about a single fact or statement and is independent. Complex proposition gives information about more than one fact or statement, contains 2 or more simple propositions, and is dependent. The truth values is the attribute assigned to a proposition in respect to its truth or falsehood, which in classical logic has only 2 values, true or false. Truth table is used to determine when a compound statement is true or false. conjunction is only true when both P and Q are true. Disjunction will only be true when either P or Q is true. And finally, negation is the opposite of the proposition. And finally, here are my references for this report. And now, let us proceed with the final assessment. First part, identification. Number 1, it deals with propositions, statements that are only capable of being true and false. He is the father of modern logic for number 2. Number 3, it is a declarative sentence which is either true or false. It must be one or the other and it can be both at the same time. Number 4, it gives information about a single fact or statement and is independent. It is used to determine when a compound statement is true or false for number 5. Now, for the second part. Determine whether the following sentences is a proposition or not. The sum of 2022 is an odd number. Number 7. Can I borrow your phone? Number 8. Today is Wednesday and the day after tomorrow is Friday. Number 9. Please turn off the fan. Number 10. According to Greek mythology, Hera is the goddess of marriage and Zeus is the god of the sky. And lastly, for 5 points 11 to 15, construct a truth table, not quantity of not P and Q. That would be all for my report. I hope to see you soon in the Google Meet class online, and I promise to further explain things and give more examples, especially with 3 or more logical variables in a given proposition. That would be all. Once again, thank you and goodbye.